Good afternoon, everybody. Thank you for joining us. Today we're going to be talking about drivetrain failure prevention tips. And within that series, we're specifically going to be talking about tires. I'm Tina Harrow. This is Bill Davidson.
Nice to be back again.
Yeah,
nice to have you.
Thank you.
Excellent.
Glad to be back in Grand Rapids.
Yeah. Beautiful city.
It is a beautiful city.
Yeah. If you haven't been, I definitely recommend coming in. That's for sure.
I haven't done a ton of time here, but I'll tell you what, it is absolutely beautiful.
Yeah, we're fortunate to have the factory set up right here in Grand Rapids, Michigan. Good culture, good city to live in. So
it is amazing. What is the square footage here?
Ooh, you got me with a riddle. We're going to have to come back to that one. We'll have to bring Dustin Snow in and have them talk with the total square footage of all the plants.
That can be another vodcast for us.
Oh, there you go. The little tour of the building.
Hey, perfect.
There we go.
All right.
Yeah, so our main topic was drive axle tires,
correct.
Right?
Yes.
Yeah. So what do you think of Weller adding drive axle tires into our portfolio? I mean, shouldn't we be selling them since we want to talk about them?
Boy, not necessarily.
No?
I mean, we are the drivetrain expert. Let's let the tire guys be the tire experts.
Yeah, that's a good point.
So,
we don't want to steal the business from them.
Yeah. Nice.
Oh, man. What we're going to do is we're going to play a little bit of the previous video we put out on YouTube. This is before we were vodcasting. So we're going to go over to YouTube, our YouTube channel, and then we're going to pull that video up, and we're going to kind of fast forward a little bit in because there's a couple of visuals I think are really important for us to help talk through this podcast. So.
Okay, great, thanks.
All right. Yeah, fast forward just a little bit more. And all right, let's watch from about right here.
Both tire pressure and diameter of all drive axle tires must be uniform. Not doing so can lead to costly repairs. Mismatched drive axle tires is caused by mixing tires that are new, used, different manufacturers, or tire designs. Larger tires will carry greater loads, and a difference in diameter will result in different revolutions per mile. This difference in rotation and torque results in excessive slip that can cause premature wear, failure, and loss of traction. Imagine tire diameter in this way. You wouldn't install a 390 ratio differential in the front axle and a 370 in the rear. Issues commonly associated with mismatched drive axle tires are going to be noise, vibration, premature tire wear or failure, excessive heat from the drive axles, binding or popping of the differentials, poor performing differential lockouts, and differential or driveline failure. Our example has new tires installed on the rear axle and used on the forward. This caused a premature failure to the interaxle differential. The excessive wear and pulled metal to all the components is caused by spinout. Using a cutaway training stand, we can visualize a forward axle spinout. Initially, the interaxle differential is spinning 1-to-1, as if the vehicle is driving straight down the road. Observe how the differential pinion gears walk around the output side gear when the rear axle is stationary. The best method to determine tire circumference and diameter is by lifting the axles off the ground, using a soft tape wrap around the tire, and then measure and record all drive axle tires. Some general drive axle tire rules. The difference in diameter shouldn't exceed 1/4 of an inch between the inner and outer tire. Difference in the circumference of the tire should not exceed 3/4 of an inch. Tires with the same tread pattern should stay within 4/32 of each other. Following these basic rules with your drive axle tires will allow the differentials to spin as close to 1-to-1 as possible when traveling straight down the road, evenly splitting torque between both axles.
So what's really interesting about that video, I'd definitely go on YouTube and finish watching it, did you notice how the tires were going in a circle and those lines weren't timed out quite right?
Yes.
Well, the big misunderstanding in the industry that I have conversations with vehicle owners about is just what a drive axle does. So the engine's horsepower and torque goes down through the transmission, makes it to the drive axles. If I have my power divider switch off, so I'm not locking my front diff, I'm still delivering 50% of that horsepower and torque to the front and rear.
Right.
Well, then it goes down to the wheel differentials and splits side to side to your curb side of the vehicle and the driver's side. And then you're getting 25% of torque applied to the ground at each set of those tires.
Right.
So basically what you're doing by mixing them is introducing a ratio discrepancy, either left and right, front and rear, which it really, depending on what product you get from us, a limited slip diff, an open diff, it changes what's happening in that system. So a limited slip diff is going to compensate speed and try to apply torque, so like a Mack differential carrier.
Right.
Yep. So they're called torque proportioning. The power divider is going to, essentially be thinking it's in a spin out, and then it's going to apply more torque to the wheels that are going slower to pull out of it. Well, mixing the drive axle tires is actually going to cause wear, premature wear, or increased rate of failure.
So brand of tire based on the vehicle.
Yes, always match the tires to what the application is. Never put steers on the rear, on your drives. Never put, drives on your steer axles. And then when it comes to circumference, you just really want to match them all evenly, not just by tread depth. So if I was to have a Michelin tire,
right, and
then I put a recap on the other axle, they may by tread depth seem right, but overall circumference of the tire would be off.
Okay.
Yep. And it ends up costing, which greenhouse gas laws, emission changes, everyone nowadays is worried about what? Fuel efficiency.
Absolutely.
Drivability and fuel efficiency. So intermixing your tires or not having a good tire management program, you end up costing yourself more fuel efficiency, more wear and tear on the diffs. So now the potential of a failure is getting more likely. And that's really relative to how much do you pull. Do you pull in grades? There's a lot of math that goes to why and what fails. What I find interesting is just it's so easily overlooked. I think, have you ever walked through a parking lot, walked by a semi with a tandem drive and seen tires that just didn't look right?
100%.
Yeah.
And so they've been out a long time, but
yep,
many customers are running super singles.
Yep.
So application and potential for damage there.
So, well, the super singles are interesting. So it's a heated topic. I've read everything from never do it. I've read I only do it. There's a lot of opinion on it. And it just comes back to, yes, a super single is good for trailers. Can you put them on a tandem drive axle? Yeah. What can you get away with? So always go back to whatever manufacturer produced the vehicle and produced the drive axle, follow their recommendations. And the main reason is behind that is if I'm a heavy haul and I'm putting a lot of deck weight down, you still want your tires to slip a little bit. So anybody that drives their car, you take a tight turn and you'll hear scuffing out of the tires. They're traveling two different distances. So if you're putting a lot of load there, it's also increasing the load that the drivetrain components have to do because you're not getting that slip. So you're building torque, you're building pressure. You could wear your suspension out a little bit more. You could break down the lube. Your oil would break down a little bit faster. So there's just a lot of mechanical aspects to it when you're deciding to change what the original manufacturer decided to do.
Got it. So what other components on the truck can be affected by poor tire maintenance?
Yeah, so not only your fuel economy, I would use that as the number one. Okay. Number two, I would get into suspension, your bushings, because now the loads applied to the ground and the pulling forces are changing. So your suspension is going to have to eat more of that.
Right.
You ever hear this saying that when one piece of the puzzle starts to wear, like your elbow goes, well, now your shoulder's got to carry more. Well, then now my neck hurts more.
Right.
It's the same theory. Is all of those are designed to work together in unison, all together, all of those parts. So when one is starting to get out of spec, the other components in that system have to start carrying more load. So your universal joints, if you're not braking torque 50-50 front and rear, and now let's say it's 2 inches of circumference difference, which is really large, you're going to apply, let's just say 70-30.
Right.
Now you're changing the torque hitting the road. So imagine all those components carrying torque that they weren't originally designed to do. And then your likelihood of braking traction to the road in a spin-out failure.
Sure.
It's pretty interesting when you get into the exacts of it. But again, it's scenario-based, ratios, torque, how big is the gap, what parts are going to wear. Does it have a rigid Hendrick suspension, or is it, an airliner where it's got, plastic pucks essentially in the suspension. So there's not one rule for all, unfortunately.
Got it. All right. Well, thank you very much.
Oh, you're welcome.
Anyway, been fantastic information. Really appreciate everybody's time.